In this video, we're going to cover the fundamentals of polynomials. For those who don't know me, my name is Chris Inazoni. I used to work as an engineer for a defense company, and I've since left that to start a career in tutoring. I make these videos so that VC students can do the best they can in math methods. With that out of the way, let's get into it. The term polynomial is used to refer to a function that is entirely comprised of a series of power functions, which just means that each term in the polynomial is x raised to some power. One more term you need to be familiar with is the degree of a polynomial, which is just its highest power. In this example, the degree of this polynomial would be 3, since its highest power is 3. When it comes to solving polynomials, we usually rely on factorization and null factor law. Let's look at a few examples. This example here is null factor law at its core. It works exactly the same as quadratics. You've got 3 terms that multiply together to equal 0. So you just go term by term, equate each of them to 0, and solve them individually. You use a very similar strategy if you have both a linear and a quadratic. This is still just 2 terms that are multiplied together, so you solve them individually. It just means that when you go to solve the quadratic, you have to also factorize that as well. Sometimes the quadratic can't be factorized, and under those circumstances, the quadratic term contributes no solutions to the overall polynomial. You can figure out whether or not the quadratic contributes solutions by finding its discriminant. In this case, the discriminant is negative, hence we know for a fact there's going to be no real solutions to it. Another thing we tend to look at when it comes to polynomials is this idea of equating coefficients. The idea is just that if 2 polynomials are equal to each other, if they're identical, then it means that each term in the polynomial has to be identical to each term of the other polynomial. In this example, we're told that f of x and q of x are equivalent, and we need to find the coefficients a and b. So we're just going to go term by term and equate the coefficients. Starting with the x cubes, we have 4x cubed and ax cubed. By observation, we can say that a must equal 4. We can say a similar thing for x squared. There are no x squared terms in f of x, so b must therefore be 0. As a final validation, if you want to error check your answer, then you can always sub those coefficients back into the original polynomial and then just see that both polynomials are identical. This is purely just for error checking though. The only thing you need for an answer in this question are the answers to a and b. It might not always be that cut and dry. In this example here, f of x is in its polynomial form, but h of x is in its completed square form. Those are 2 separate forms, so it makes it very hard to compare both of those polynomials together. The most direct approach here is just to complete the square of the first polynomial. That'll get both polynomials in completed square form, then you can go term by term and see what each of them must have been. If you want, you could also expand h of x instead. Remember, the only issue is that we want to try and get both polynomials in the same form. This is a bit harder, however, because now you're in the land of simultaneous equations, and you've got to be very strategic as to which ones you solve first. That being said, it still works, so feel free to choose whichever one makes sense to you. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool, you should check it out. I'll see you there.